Okay, we're going to be looking at Chapter 10, Radical Expressions and Equations. This is Section 10.2, Simplifying Radicals. To start out, a radical expression simply means that we have an expression that has a square root symbol or a root symbol of some time. It doesn't have to necessarily be square root. It could be cube root, fourth root, fifth root. All right, so the property of multiplication for square roots tells us that if we are multiplying two square roots together, we can actually put that together as one square root. So the square root of 48 can be broken down into square root of 16 times the square root of 3, or square root of 16 times the square root of 3 can be put together into the square root of 48. What we want when we simplify square roots is we do not want to have a perfect square left inside the square root. So what I mean by perfect square, square root of 16 is a perfect square. Square root of 16 is 4. So we would want to simplify that, if possible, to a 4. The square root of 3 doesn't simplify, so that stays the square root of 3. All right, so there are some perfect squares that you should have memorized. If you don't, I would definitely write these down so you have them on hand. 1 squared is 1, so these are the perfect squares right here. 2 squared is 4. 3 squared is 9. I'm not going to keep going with figuring out how we get these, but 25, 36, 49, and probably up to 12 squared would be sufficient for what we're doing. Okay, now there may be some that go to like 15 squared, but you can always use your calculator to try and find those perfect squares. Now, there's a couple ways that you can look at this, a couple ways you can think about this. One, we can break this down into the prime factorization. So we have 72, let's see, 72 breaks down to 8 times 9, 8 is 2 times 4, 9 is 3 times 3, and then 4 is 2 times 2. So we have 2, 2, 2, 3, and 3. These doubles we can actually put together and make perfect squares out of those. So the square root of 72 can be broken down into the square root of 4, the square root of 9, and the square root of 2. Because 4 times 9 is 36, 36 times 2 is 72. So all I did was take 72 and break it down, but I'm trying to find these perfect squares. Why? Well, because the square root of 4 is really 2, the square root of 9 is really 3, and the square root of 2 is really the square root of 2. It doesn't simplify. So we can take these square roots out of the root. So 2 times 3 is 6, square root of 2. Everything's multiplied here. So these pieces, when we separate them, are all multiplied. When we put them back together, we're multiplying. Now, that's one way you could go about this. Another way you could go about this is you could try and find the largest square root from our list here, the largest square root that can be multiplied by something to make 72. So if you play around with them for a little bit, you'll see that 36 times 2 makes 72. The square root of 36 is 6. The square root of 2 does not simplify. It's a decimal answer, and we get the same answer. Okay, so either way of looking at it. So some of you will want to probably break them down with prime factorization and then try and find those perfect little pieces that can be put together. Some of you will just try and find the biggest square root that comes out. Square root of 125 is another one we can look at here. We could break it down. 125 is 5 times 5 times 5. These two 5s, if you put them together, make 25, which is a perfect square. Square root of 25 is 5. Square root of 5 does not simplify. So that would be your answer. Okay, keep that list handy. Square root of 160. Let's see, what times what makes 160? Well, we could try things with 2 2 times 80, 4 times 40, but we need perfect squares. 4 would work. As a matter of fact, if we start with 4 times 40, square root of 4 comes out as 2. Square root of 40 then is still there. The problem with doing that is square root of 40 still simplifies. 4 times 10 is still has a perfect square in it. So now we would have to take that square root of 4 and make it a 2, and the square root of 10 is still there. So putting this back together, 4 square root of 10 will be our final answer. Now, personally, I like to try and find the larger square root, and the larger square root would be 16 times 10, because 16 times 10 is 160. 16 is a bigger square root than 4, so I'm going to take the square root of 16. Square root of 16 is 4. Square root of 10 does not simplify, and we end up with the same answer. Either way you do it. All right, 2 more here for this lesson. Square root of 57 times n to the 7th power. Well, the square root of 57, you can try finding a perfect square. It does not simplify, so we're just going to leave it the square root of 57. We have n to the 7th here, though, that we need to try and simplify. Well, if you think about the square root of n squared, does anybody know what that simplifies to? Remember, a square and a square root undo each other, so the square root of n squared simplifies to a just plain old n. So we want to break this down into as many n squareds as we can. Well, n squared, n squared, n squared makes n to the 6th. We still have another n there to make n to the 7th. These n squareds that are square rooted will simplify to plain n's. This square root of n does not simplify. So our final answer, we have a 57, 3 n's that came out, and 1 n that didn't. So n to the 3rd power, square root of 57 and n. We almost always will put the number that came out in front of the square root symbol. So those perfect square things will go outside in front of the perfect square. All right, the last one. We have a negative sign here, I believe, so we want to make sure we remember that we have a negative in our answer. 243. 81 times 3 is 243. And we also have a square root of x, a square root of x, and then one more to make 5. So 2, 3, 4, 5 to get the square root, or the 5th root. Square root of 81 is 9. Square root of x squared is x. Square root of this x squared is x, and this square root does not come out. So our final answer, we want to have the 9 and the 2 x's, so 9x squared out in front. The things that didn't come out of the square root are the 3 and the x, so they're going to stay inside. And this is what our answer simplifies to. I just remembered to bring that negative down so I didn't forget it. All right, that's the first part of simplifying square roots.